Good evening, everyone. Today, I will be presenting my final project, which is a text based adventure game. This project showcases the use of various programming concepts that we have learned throughout this course. That includes data structures, algorithms, and object oriented programming principles. The adventure game is a text based interactive game where players navigate through different rooms. They pick up items and they manage their inventory. The game is both entertaining and educational, as it involves exploring a virtual world, solving simple challenges, and managing resources. The game includes event processing, where actions like picking up items are recorded and can be processed later. A recursive function is implemented to count the number of items in a player's inventory. Now, I will demonstrate how the game works. I will show you how to start the game, move between rooms, pick up items, and check the inventory, process events, and use a recursive function to count items. Let's begin. Now I will demonstrate how the game works. I will show you how to start the game, move between rooms, pick up items, and check the inventory, process events, and use a recursive function to count items. Let's begin. First, I'll start the game. You'll see a welcome message and the description of the initial room, which is a living room. To move to another room, you use the move command, followed by the direction. For example, to move to the kitchen, you type move north. To pick up an item, use the pickup command, followed by the item name. For instance, to pick up the knife, type pick up knife. To check your inventory, use the inventory command. You can move back to the previous room by typing move south. To pick up a key in the bedroom, type pick up key. Sometimes there will be items in the room that are not mentioned, but there might not be any items at all. If there is no item, it will say no such item here. Now let's move to the bathroom by typing move east. Let's try to pick up the key again. As you can see, the key was in this room. It timed out, so I have to restart it. Let's move north. Let's pick up the key, or let's pick up the knife, actually. Let me check the inventory. I can process events by typing process events. I can count the items in my inventory by using the recursive function by typing count items. You can go back to the previous room by typing back. You can quit by typing quit. Now let's dive into the code. I'll explain the key parts of the code and how they work. The game is implemented in Java using object-oriented planning principles to structure the code effectively. The game uses several key data structures. It uses array lists, which are used for storing inventory items. It allows dynamic resizing and easy management of the items. It has hash maps, which are used for storing room connections, allowing quick lookup based on the direction. It uses stacks, which are used for tracking the player's movement history, which enables the backtracking feature. It has queues, which are used for handling event processing, which ensures the events are processed in the order they occur. Here's a snippet that goes over the data structures from the overall code. The first important algorithm is moving between rooms. The player inputs a command to move in a specified direction. The game checks if the direction is valid from the current room. If valid, the player moves to the new room, and the previous room is pushed onto a stack. If invalid, an error message is displayed. Here's the code for the moving between rooms. The second algorithm is picking up items. The first step is that the player inputs a command to pick up an item. Then the game checks if the item exists in the current room. If it exists, the item is added to the player's inventory and an event is recorded. If not, an error message is displayed. Here's the code for picking up the items. The third algorithm is a recursive function for counting items in the inventory. The function starts counting items from index 0. If the index is beyond the size of the inventory, the count is 0. Otherwise, it returns the 1 plus the amount of items from the next index. Here's the code for the recursive function. Let's talk about what could be added or changed in the next version of the game. Additional rooms and items. Expanding the game world with more rooms and more diverse items would make the game much more interesting. Complex challenges. Introducing puzzles or enemies could add more depth and complexity to the game. Graphic user interface. Developing a graphical interface would make the game more visually appealing and accessible to a wider audience. In conclusion, the adventure game demonstrates the use of various data structures, recursive functions, and object-oriented principles. The project meets the specified requirements and provides a solid foundation for future development. Thank you for listening to my presentation.